Welcome to The Explainer. Today, we're diving into the absolute foundation of occupational health and safety. Every single day, millions of people head to work, and behind the scenes, there is this massive, invisible architecture of safety protocols making sure they can go back home exactly as they arrived. But before we can even talk about safety gear or emergency action plans, we really have to start at square one. We've got to understand the core element that makes all of this necessary in the first place, the hazard.
To get a sense of why this topic is just so incredibly crucial, take a look at this rusted, abandoned tank from the 1984 Bhopal disaster in India. Inside that tank, methyl isocyanate, MIC, a highly toxic gas. Back on December 3, 1984, the failure to properly identify, respect, and control a massive chemical leak led to literally one of the worst industrial catastrophes in human history. The safety systems designed to contain the leak, none of them were operational. The gas just spread right through the city. It's a haunting reminder that in the world of occupational safety, we aren't just dealing with abstract concepts on a whiteboard. We're dealing with life and death, and the absolute necessity of understanding exactly what threatens us.
All right, Section 1. What exactly is a hazard?
So, before disaster strikes, let's pin down exactly what we're talking about here. Now, it sounds like a simple word, right? We use it all the time. But in our field, it has a very specific operational definition. According to the Institution of Occupational Safety and Health, IOSH, a hazard is, quite simply, anything with the potential to cause harm. Notice how broad that is. The harm isn't just limited to a worker breaking an arm. It's defined as injury or damage to the health of people, sure, but also damage to property or damage to the natural environment. A hazard is pure latent potential. It's a coiled spring. It's the chemical just sitting quietly in a vat, or that heavy, suspended load hanging from a crane.
In industrial and transport settings, this potential for harm often shows up as dangerous goods, widely known as hazmat. We're talking about materials that are radioactive, flammable, explosive, corrosive, toxic, you name it. We're also talking about physical conditions. Think about compressed gases, compressed liquids, or dangerously hot materials. And here's the vital thing to understand. These materials pose a profound threat even when they aren't actively doing anything. Even when they're just sitting completely dormant in a storage room, the hazard, that pure potential for harm, is 100% present.
Okay, here's where it gets really interesting, and honestly where the general public constantly gets mixed up, the difference between a hazard and a risk. Distinguishing between these two is the absolute bedrock of safety science. Like we just established, the hazard is the mere potential for harm. Risk, on the other hand, that's a calculation. Risk combines the likelihood of a hazardous event actually occurring with the projected worst consequence of that event. Think of it like this. A shark swimming in the ocean is a hazard, period. Now, if you're standing safely on the beach, the risk is incredibly low. But if you're swimming in that water with an open wound, the risk is extremely high. The hazard didn't change at all, but the risk absolutely did.
Moving on to Section 2, Spotting the Danger.
Since we know the difference now, how do safety pros actually go out and hunt down these threats? Because if a hazard is pure potential, our number one job is spotting it before that potential turns into reality. When we're dealing with massive, complex systems, like a chemical processing facility or a huge manufacturing plant, we rely on what's called a Hazard Inoperability Study, or HAZOP. This is pretty much the go-to hazard identification tool in process safety. A HAZOP is this incredibly structured, systematic examination of a facility. The whole intention is to review the process or the machinery through all phases of the product's entire life cycle. It's perfectly designed to catch those sneaky design and engineering issues that might easily slip right through the cracks of a standard safety check.
But what about everyday tasks? Well, for that we use a Job Safety Analysis, or JSA. A JSA is a procedure that basically bakes accepted safety practices right into a specific job operation. First, you pick the job and record the steps. You literally break the task down into a sequence of actions. Then, for every single step, you identify the hazards, both the ones produced by the environment and the ones connected directly to the work. From there, you assess the risks, and finally, you develop control measures to ensure it's done safely. Putting together this complete, accurate list is basically how we map the battlefield.
Once a hazard is identified, whether through a JSA or a HAZOP, we have to evaluate it using a risk matrix. You assess the existing risk by taking the likelihood of the event occurring on one axis, and you weigh that against its potential severity on the other. As you can see, severity can range from a tiny first aid injury on the far left, right up to catastrophic outcomes, like multiple fatalities on the far right.
Likelihood goes from rare at the bottom to almost certain at the top. Where those 2 points intersect, that gives you a numerical score and a color code, which instantly tells you exactly how aggressive your safety response needs to be.
Now let's look at how this risk evaluation actually builds into a real strategy of defense. This diagram brilliantly maps the journey of a hazard toward causing harm, and it's just a phenomenal way to visualize safety. On the left, you've got the hazard. In the center, you have the critical moment, the loss of control. To stop the hazard from ever reaching that center point, we use prevention controls. These are your upfront barriers. But if those fail and an event actually occurs, we cross over to the right side of the diagram. Here, we rely on mitigation controls. The event happened, yes, but these controls are standing by to reduce the severity of the damage.
Which brings us to Section 3, the hierarchy of controls.
So, you've mapped the hazard, you've quantified the risk on the matrix, and you understand prevention versus mitigation. How do you actually neutralize the threat? How do you build those barriers? Well, the answer lies in this upside-down triangle. This is the hierarchy of controls, and it is a foundational concept in this field. It prioritizes risk control types, ranking them from the absolute most effective methods up at the wide top down to the least effective methods at the narrow bottom. The golden rule here? You always start at the top of this triangle, and you only work your way down when the higher levels are literally impossible to achieve.
Let's look at those highly coveted top tiers. The absolute best control is elimination, physically and entirely removing the hazard from the workplace. Dangerous chemical? Just don't use it. If that's a no-go, we move to substitution, replacing the hazard with a less harmful solution. Think swapping a toxic solvent for a milder alternative. If the hazard absolutely has to stay, we use engineering controls. These are physical modifications to the workplace that isolate people from the danger, like putting a heavy, soundproof enclosure around a deafening generator. These top 3 are the gold standard because they remove the human element. The worker doesn't have to remember to be safe.
Now, if the risk is still hanging around after all that, we have to drop to the bottom tiers, which are considered the least effective. First up are administrative controls. These alter how the work is actually done. Safety policies, training programs, shifting schedules to limit exposure time. Finally, the absolute last resort is personal protective equipment, or PPE. Hard hats, respiratory gear, even the fancy new smart PPE with sensors. Why is PPE at the very bottom? Because it relies entirely on human reliability. If a worker forgets to put the mask on, or it slips, the hazard strikes instantly. PPE doesn't eliminate the hazard, it's just a final, desperate shield on the worker's body.
In a truly robust safety culture, all of these puzzle pieces, the hazard IDs, the risk matrices, the hierarchy of controls, combine into what we call safe systems of work. These are systematic examinations designed to minimize risk. And the ultimate goal of a safe system of work? To tame what we call residual risk. Residual risk is whatever danger is left over after all your controls are firmly in place. The whole objective is to squash that residual risk down to a level that is as low as reasonably practicable. Basically, a state where the risk is acceptable and just won't cause significant harm.
To wrap up this explainer, I want you to do me a favor. Just take a second and look around your own workspace right now. Could be an office, a warehouse floor, a construction site, wherever. Ask yourself, what everyday hazards, what latent potentials for harm are hiding right there in plain sight? And honestly, more importantly, when you look at how you're protected from them, do you have the right high-level prevention controls in place to stop an event before it even happens? Or are you just relying on a hard hat as your only line of defense? Understanding the hazard is the first step for sure, but actively controlling it, that's what saves lives. Thanks for hanging out and learning with us, and hey, stay safe out there.